Hi guys, I'm just going to do a recap here of day 2. I'm not going to do every question. This will just be because there were a couple people that were absent on Friday. So if you were absent Friday, please make sure you watch this video. All right, so the first 3 challenge questions are important questions from day 1. Remember, you can pause the video, replay the video. I'm just going to teach through. Okay, so first question just asks you to find the common difference. So we just use the common difference formula, second minus first, when the terms are right next to one another, and we get a common difference of 4. The next one, the terms were not right next to one another. You can see that I have the second term and the 10th term. So when they're not right next to one another, we're basically just using the slope formula, and we're going backwards. The term going backwards minus each other, and then you subtract the positions, and we get a common difference of 5. And then we saw that we have this nice explicit formula for an arithmetic sequence that could be used to find any term. And we plugged in the first term, our 30 for n, and our common difference, and we got 10. So those are nice questions to know for when I do give you a test on this. Okay, so day 2, what I did on Friday, was called geometric sequences, and Friday's lesson just paralleled Thursday's lesson, except the only difference is we're not adding the same number, we're going to be multiplying the same number to produce a new sequence. And we don't use the formula common difference equals second minus first. Instead, we use this formula, the common ratio. So common ratio is second divided by first, and we get 2. And if we keep multiplying by 2, multiplying by 2, multiplying by 2, we get what's called a geometric sequence. Remember, you don't have to be right next to one another. If I did 60 divided by 80, I also get 2. Just like the arithmetic sequence had an explicit formula, geometric has its own explicit formula as well to find any term in the sequence. On Thursday, we graphed the points for an arithmetic sequence, and we saw that it produced a linear function. When we graphed the points for a geometric sequence, so like first, oops, that marker is too fat. So first, second, third, so if we come over and we graph them over here, so 1, 5, 2, 10, 320, we can see that it produces not a linear function, but an exponential function. So we want to try and relate those two things together. Geometric functions are really exponential functions. Okay, so let's do this question here. First thing they're going to ask me, is the sequence a geometric sequence? Well, I'll find the common ratio if it exists. So I'll do second divided by first, and I get 3. Is this a times 3 pattern? On Friday, I had you guys do 4 times 3, enter, times 3, enter, times 3, enter. So if that sequence is produced, we can say yes, because it's a times 3 pattern. If I wanted you to find the 10th term, we would just use the explicit formula that I just showed you on the previous page. And I want to find the 10th term, so I would just replace the n's with 10s. Oh gosh. So a sub 10 equals the first term times the common ratio to the 10 minus 1, so we can make that a 10 right there. And a sub 10 is going to equal 78,732. Please make sure you guys are using your calculators to plug all of this in. You got to be practicing. Okay. On Friday, we also did a question very similar to the arithmetic, where what if the terms are not right next to one another? So our first thing says the first term is 5, and then we have space between, and the 6th term is 12/15. So we can't just do our common ratio formula of second divided by first because they're not right next to one another. We still will divide them going backwards, but then you're going to take the root going backwards of the difference of their positions. So you just have to memorize that. So our common ratio for this guy would be 3. And just plug that in the calculator. You use the control and 2 below it, so you could put that 5 in and put your quotient in. All right, so they asked me for the first 7 terms. We have the first one, times 3, times 3, times 3, times 3, and I'm going to squeeze 7 down here. And there we go. Alrighty. We'll just move on. We're just doing a recap. We're not doing every question. Okay, and this one is super important here. So it says, since a geometric sequence can be modeled by an exponential function, we might have to convert the percent of increase or decrease into the common ratio. All right, so look, we see this percent right here. Remember in our last unit for the exponentials, we would take our, oops, I gotta get used to not using these fat pens here, okay. We would take our percent and turn it into a decimal. So it would be 0.04. But the common ratio isn't gonna be 0.04. If I read this question, it says that Naya is training for track season and decides that she will run 4% more. So this is an increase. If you multiply a number by 0.04, it's going to become smaller. So remember what we would do in the exponential unit? In the bubble, remember it was either 1 plus r or 1 minus r? So I'm going to do 1 plus the rate. So my common ratio is going to be 1.04. I don't know if you can hear my cat crying. I guess this is going to happen every day. All right, so if she runs 12 miles week 1, represent the geometric sequence. So you're just going to do 12 times 1.04, enter. Then take 12.48 times 1.04, enter. And make sure you give me everything. And there we go. So this is a super important question. If it was decreasing, we would do 1 minus 0.04. And let me just see what else we need to finish. I think we just have one more. You can get the notes, have somebody send you for these other ones. Okay. Last one. Super important question. So it says the 8th and 10th terms of a sequence are 64 and 100. If the sequence is either arithmetic or geometric, now that's interesting. They're telling me it could be either one. The 9th term cannot be. All right, so I like charts. Let's make one. And let's set this up. So it says that the 8th term is 64, and then I have space between, and the 10th term is 100, and I'll do that over here as well. So first thing I'm going to do is find the common difference, but I notice again it's space between, so I can't just do second minus first. I have to do the slope formula. And we get a common difference of 18. If the common difference is 18, the 9th term is going to be 82. So 82 can work. Let's do the same thing for geometric. Common ratio. Oh my gosh, if you hear the cat crying, sorry, she's trying to get into my daughter's bedroom, but I'm in the middle of doing this video, so I'm gonna wait. Okay, so there's space between them, so we can't just divide them. We will divide them. Oops, this is 100. Okay, so 100 minus 64, 10 minus 8, and we get a common ratio of 1.25. Okay, so if I multiply 64 by 1.25, I wind up with 80. So I go back up here, and 80 can work too. But there's something unique about a geometric sequence. This technically could be plus or minus 1.25. A geometric sequence, if you multiply by a negative number, you're going to get alternating signs. So this is technically plus or minus 80. And think about it. A negative number times a negative is a positive. Positive times a negative is a negative. So geometric sequence can have alternating signs, but an arithmetic can never. So therefore, this could work, but this could never work. All right, guys, that's it for the recap on day 2. Now I'm going to get into day 3, but you can look here in the packet. There's more practice questions you can do. Obviously, these with the worked out keys, super important that you know how to do this, bringing back slope, and that's it.